right, now let's talk about the ideal gas law. Now, before I get going, the world is not a perfect place, by a long shot. So, this law talks about ideal gases. There are no ideal gases. There is no such thing. However, when it comes to understanding the interaction of gases, this gives you a pretty good idea of what's going on. It assumes that there are absolutely no interactions between gas molecules or gas atoms. Absolutely none, which again we know not to be entirely accurate. Excuse me. So anytime you have a large amount of gas or a very high or a very low temperature, very high, very low pressure, things kind of tend to go awry. But as long as you kind of stay within a reasonable range, this law will give you all the relationships between pressure, volume, amount, and temperature that you could need, particularly in an introductory chemistry course. There is something called the real gas law, which has several constants in it that are particular to the gas that you're dealing with, that will account for those possible interactions and other weird things that happen in the real world. However, for our purposes, we're going to stick with the ideal, and this law is affectionately known as Pvnert or Pervnert. P equals nRT. P stands for pressure, as previously discussed. This pressure must be in atmospheres. Now all of a sudden my units matter, and they matter quite a bit. So pressure must be in atmospheres. V stands for volume, which must be in liters. N still stands for amount, it has to be in moles. R is a constant, it does not change. And the R constant that we use up there, 0.0821 liter atmospheres per mole Kelvin. And notice all of the units of my other variables are present in that R. That's why we have the units that we do. If you are not in my particular chemistry class, your professor or teacher might use a different constant, which may mean that you have to use different units on these particular variables. In my class, we always use this R, which means we always have to use these units. Then temperature is the last one, and it has to be in Kelvin. So, for example, this is the same sheet I was working on before, and it says if I get to the edge, how many moles of gas are present at 36 liters, 15 degrees Celsius, and 85 torr. So notice there is no change. This is one situation, and we're just trying to figure out as much information as humanly possible about this one situation. That's how I know this is a Pvnert problem, because there's no change, nothing added, nothing taken away. So, stuff that looks useful. How many moles? That sounds like what we're looking for. Of a gas, so this is a gas law problem, are present at 36.5 liters. Liters, that's my volume unit. 15 degrees Celsius, that's my temperature. Oops, I just wrote that again, goofball. And 825 torr. I'm just all kind of off kilter today, I apologize. Before we move any further, let's check our units. Since I have these variables, I know this is going to be a Pvnert problem, which means I know I have specific units. N will come out in moles, so no converting I need to do to get the final answer. V has to be in liters, he's good. Temperature, though, has to be in Kelvin. Right now I'm still in Celsius, so I got to add 273. Gives me 288 Kelvin. Pressure, also, gotta be in atmospheres. Torr is not good enough. So 760 torr equals 1 atmosphere. So 825 divided by 760 gives me 1.0855 atmospheres. A word about decimals. If you're going to use a number again in a problem, it's always good to carry out as many decimal places as you can stand. Every time you round within a problem, you're introducing error into that final result. And if you do that enough, ultimately your answer might be completely wrong. You're just that far off. So like this number here, I know I'm going to use it again in my Pvnert equation, so I went ahead and carried out 4 decimal places. We know R is a constant, as we mentioned before. Let's see, I'm looking for my N. So RT is being multiplied on this side. I got to divide both sides. So that gives me PV over RT equals N. Just shove in your numbers and that should stick out our answer. So 1.0855 times my volume divided by R times T. How many sig figs can I have? Looks like 2, so no more than 3. 1, 2, got around 3 moles. Now, if the problem told you what you were talking about, your answer would also need to include the thing. But they didn't. I just have moles. So there we have it. Let's do one more example before we close out this one for today. Let's go ahead and just look at number 7 here on my sheet. It says 59.61 grams of ammonia. So I have a thing this time. Is at NTP, what is the volume? So nothing's changing. We didn't add or subtract. So before I even start writing down variables, I'm pretty sure this is going to be another PubNert problem. The only thing that I have that involves anything close to grams is my N. But my N can't be in grams, it's got to be in moles. To convert from grams to moles, I need my formula mass. Ammonia is NH3, so I'm going to need 1 N and 3 H's added together. So 59.61 divided by that formula mass gives me 3.4982 moles of ammonia. That seems to be all I had. But remember we talked about those abbreviations, STP and NTP. NTP was normal temperature and pressure, so it will give me both a temperature and a pressure. Temperature was 293 Kelvin, and pressure was 1 atmosphere, and they ask me for the volume. R is a constant. I'm looking for V, so I got to get the V by himself, means I need to get rid of that P. So V equals nRT over P. Just plugging in my numbers, 3.4982 times R times T divided by P. How many sig figs can I have? Looks like 4. Whenever we're doing volume in a PubNert problem, my answer has to be in liters. Whoops, forgot my thing. There it is. So those are PubNert type problems. Quick review, remember that PubNert problems always involve the same set of variables. There is no change. So nothing has been added or taken away. It is just finding information about one set situation, one volume, one temperature, one pressure, one amount. If you change any of those, PubNert's not going to be the equation of choice. Remember that units matter in PubNert problems. Temperature must be in Kelvin, as per usual. Pressure needs to be in atmospheres. Volume needs to be in liters, and amount needs to be in moles. So there come those mole conversions again. Be careful. Last thing to mention, if you're going to use a number again in a problem, always carry out as many decimal places as you can stand to prevent possible rounding error from cropping up later. The next step in the gas law journey is to go into gas law stoich. So we're going to reintroduce a little bit of stoichiness in with these gas law type problems. See you next time.